All right, so our slides are really actually Emma, but I threaded this one in because Emma had been kind enough to send me a picture of Ross and Rocky or whoever they are. Okay, but anyway, it was funny as I was making the slides today. I think Morgan came up and said, "Oh, that looks like kind of like Emma," because it is Emma. It is Emma. Is that the cutest thing?
I'm so chubby.
Most of the pictures, your brother looks like "Stop hugging me."
Yeah, I know. He doesn't want to hug me. He doesn't want to hug me, but I want to hug him.
Yeah. I think this
Still
next
the
one's.
same.
Let's see.
Yeah, it's okay.
I left out the one of your mother on the beach in her swimsuit, even though she was covered.
Yeah.
I didn't know if she really wanted to be in the slides in her
she's fine,
swimsuit.
but yeah.
That's kind of
I mean,
a cute
I'm in
one.
my nightgown, so.
Yeah. Oh, was that a nightgown? Oh, there's a cute little sundress.
I don't know. I don't really know.
So sweet. Is this in your apartment? Do you have a lion in
No,
your
this is in
apartment?
Jamaica.
Family peg.
Oh my god.
That's
Do I look like a frog in that?
It looks just like you.
Oh, you stand?
No, I don't. I think it's so cute.
Yeah, my mom is beautiful.
And your mom looks like the youngest one in the picture.
My mom is so beautiful. Really amazing. I know.
That was, he was being kind of sweet there.
Yeah. Well,
Yeah.
that's a different brother.
Oh, different brother.
Yeah, that
Gotcha.
one likes
They
it.
look kind of alike.
Yeah.
Yeah. So, anyway. All right. So, send me pictures. I love to incorporate them. So, on this slide where you don't really need to see any of my writing, we're going to make a list of food that you're going to bring to the next class. Actually, I'm used to having like 2 or 3 AP Cal BC classes with about 25 to 30 people in it at my other school, so it was really in a classroom. So it was really fun when I did this. I would stand up front with a knife and a cutting board. That was illegal, I'm sure, at the public school I was teaching at, but I snuck it in through the metal detector. But anyway, I'm like, so they're coming for me soon. I'm sure they're watching the video. So I'm like slicing and throwing. Like, I mean, cutting up an apple and just throwing slices and people catch them or pick them up on the floor or whatever. So I'll be able to like stand right here and hand you food. And we don't really, I always end up with too much food for this, so let me make a list of things that I would like to have, okay? So,
Okay.
apple, we could have a pear. If anybody, let's see, let me think of some other things. Kit Kat bars.
Ooh.
Make sure that anything you bring in food is, now I do have a friend that is deathly allergic to kiwi fruit. So I guess you can always make sure that you bring in food that isn't gonna hurt someone, but just be careful, okay? I don't know anybody who are deathly afraid of kiwi fruit. Let me think what else we need. Something
Pringles.
I thought about Pringles. We'll have them just for fun. I can do some crackers.
Sour cream and onion.
Those are the best.
Cheese and crackers.
Cheese
Cheese and
board.
grapes.
Charcuterie.
Charcuterie.
Toblerone. Like,
Toblerone.
how do you spell that? Yeah, they're triangular, and I think you can get them sometimes at like Twain Reed or maybe Food Emporium or Mercedes. I think I've seen them out there somewhere. I really need them. Let's see what else we need. What else has been fun to have in the past?
Tostitos. What is this for? Tostitos and lime. Huh? Those are so good. Oh wait, I already have a bag of Tostitos. Did you get my email?
Yes, I did. I found it very funny.
Sun
You told me
chips.
about it.
Garden salsa.
Muffins. Just one?
I wish Neos was still here. Goodness gracious. Neos needs to come back right now.
Teaching you how to find volume
Say.
instead of area.
Can we bring Oreos? Tostitos, ketchup,
We sort of do it anyway. Really, I kind of like, I'll do it for fun. You've seen other classes here. It's fun to max them in.
Reese's peanut butter cups.
That picture actually perfect. I need something of that shape, and a muffin kind of gets that. What else is that Reese's shape?
Can we bring in like Jello?
Oh, they have those little
You know,
ones
like
that
those
have
Jellos that are-
caramel in them.
Rolos.
Oh, yeah,
Really big
Rolos.
ones that are like shaped like.
But they're
Yeah.
straight up and down, aren't they?
No, Rolos are like
small.
they're a little bit.
It's like a cone if you take off the cone.
I love Rolos. Triangle.
Oh, we
We
could
do
do
a
ice
big
cream.
Jello. I just decided that.
The little mini ones. that you
You know the ones where they like.
dip them in chocolate.
So much Jello.
Wait, what have I got in
I used to do
Jello.
one in where is it?
I don't need Jello, but you can bring some.
Okay.
I used to do three.
I just think it'd be hard to cut. Do like a sliced Jello, I think.
It would be hard to slice it like into like a decent like shape.
Yeah, I mean, you can make it into so many things, and actually some teachers do this with Play-Doh. So you can make whatever shape, and then you can cut it with like a dental floss. But I figure y'all probably rather eat things.
Yeah, I love to eat.
Put Jello in a bun cake. We should drink pasta.
I don't
Yeah, why don't you do
I thought you were
that?
saying just those like Jellos that like you take the lid off and they're like
Oh, an any pan.
Oh,
Something.
was it?
Sushi. Sushi.
What
Yeah,
do you
over
think?
to any
At first I
chicken.
thought it was like.
Something.
But they don't even
Spring
know
rolls. What's the actual one?
It's some brown rice with like, who's bringing
Steak.
it? Sushi.
Or maybe like something. Cinnamon rolls. Oh, actually, like,
I
they
think
do that well.
I
They
was
do like the
thinking
rice
brown
the same. It usually tastes like.
Can't take the bowl.
Dumpling. I mean, I don't know if I'm a big. I love pencil. I love pencil pieces. Here, I'll give you a quarter of mine. I've had the same thing for my 2 years ago.
Oh, yeah.
Look how many
Like,
steps.
these like Hostess cupcake things, they taste like plastic, but I like them. Those would be great, like I really like those.
It's like,
Um,
what about a Twinkie?
Twinkie would work.
Do they even make, didn't they like retire Twinkies?
They might be banned from existence, I don't know.
donuts?
Donuts might work, but
I like devil. Yeah, you could do one cake.
I do, a bundt cake would be good, actually, but I don't know if anybody wants to volunteer for a full
That's the
bundt.
same as a donut.
Yeah.
Yeah.
Yeah, I could do the same thing with it, but it's bigger, so it's easier to do. Let me see if there's anything I'm forgetting. Oh, watermelon. Let's see. Oh, chocolate kisses. All right. So, kisses with no nuts in them.
High chews.
And a cake of any kind. But I can also accomplish what I want without it. All right, now this is, yeah, well, I can do something with the sushi. So if we bring it after? Yeah, y'all be able to eat some, and I'll have leftovers. Okay, this will be plenty. Please don't bring a bag of apples or anything, just one is fine, okay? All right, so look up here and think which one you want to claim. It'll be part of your homework to bring it, okay? Part of your homework. So don't forget. All right, hang on. Sophia had her hand up first. All right, so one apple. You can bring more than one if you want, but one is all I need to slice, okay? Emily? All right.
Green sour cream and onion.
Okay, so that one's taken, that one's taken. Okay, Rose?
I'll do Hershey Kisses.
All right, so Rose. So I'll have a record of this on my slides. Okay, I'm just gonna go around the room. I'm sorry, I may not be getting the person that like you may be taken by the time I get there. So I'll jump back and forth. Celine, sorry. And back. Okay, what? I don't know that you can ever have too many Kit Kats, and there'll be some left over, because I don't think I have 14 things up here. Alana? Okay.
Someone just, what kind of cake does cake and
Okay, Elena? Good, awesome.
Wait, what kind of, like, does this cake need to be in any, like, shape?
No, it can be any shape. Are you bringing a
Can
cake?
you bring a Fudgy the Whale cake? Can you bring Fudgy the Whale?
No, no way.
It would melt though.
Okay, Casey, did you bring one?
I could bring in
Okay.
How big do the muffins?
Wait, when is this is for next class?
Yes.
I have to bake a cake in between now and then.
You can try one in the bakery.
No, I'm gonna bake it.
Oh, you're so
Um,
nice.
Like I bought one on the way to school, it's one of those food chairs for like $1. But they can be mini muffins or big muffins.
last.
Like they're big.
I know. I'm so excited. I hate those stories.
Except I'm doing
Food trucks. Oh my god, are you serious?
Okay,
Funfetti cake. Can I bring
No.
where are you bringing the cake?
CK, I am not making, I'm not spending hours of my time to make
Where are you gonna get the sushi?
Alright, sushi?
Oh my god, I'm so
My red velvet cake, my red velvet cake slaps.
Or they sell sushi.
My red velvet cake slaps. So
Where?
I'm bringing in
Yeah, are you okay with that?
I have a
Oh my
in my
God.
fridge right now.
You have a what?
I do. I have the little Pillsbury roll in my fridge right now.
Perfect, okay.
Oh,
With the white icing?
Yeah. I'll save the icing so we can put it on here and it doesn't get soggy.
Okay, now, raise your hand if you didn't claim something. Did everybody get something? Do I have that many?
I don't, but it's okay. I don't have any.
Oh, you don't, but you're okay?
Yeah.
Oh, you'll just eat.
Yeah. Yeah.
And you and Anna can just.
Yeah, that's alright. Unless there's something else you want.
If I think of something that would be awesome, I'll send you
Okay.
a request.
So I know I'll get an awesome.
Alright, so. Yeah, we need to give you something.
just use into wine.
So that you can get your homework ready.
Oh, facts. Well, you can just give me.
Can you bring a loaf of bread?
I like bread.
What was the
Yeah.
Yeah, do a good.
Like Italian
Banana
bread,
bread.
or just like a loaf of French bread?
Banana bread.
Banana.
Or-
Banana bread. Wow. It's not a loaf of bread.
Or do
And you can bring a loaf of banana bread. You can go grab one at,
Lapan or something.
yes.
Or Fairway.
Yeah. Just
So
any,
maybe that's not far.
you know, just any kind of bread. Okay, Emma?
Sounds good.
Alright, so Emma's bread.
Should I bring some butter and jam? Yeah. Can this just like I honestly I don't think that we
She moved up and she moved up and
like
Did
it's
they ever
just
call
so
you
good.
Karen?
Like, I don't know what we did.
Yeah. And then
Why?
I mean, no, you weren't. Not for gender something. I would rather be called like
I
Carol.
know how to get bread there.
Oh,
like,
really?
like,
Yeah.
Because there's so many variations of my name, like Rebecca, like Rita, Becca, in my book, there's like a prime minister that I'm listening
No,
to.
just get the butter.
No, no, no.
Prime Minister Caroline,
My whole friends like thing.
former wife is Caroline, I think, and Carol Caroline.
Interesting. Well, because
Or Caroline.
that's what I use all the time. No one else really calls her Carol.
Just went like we were all watching her and the waiter.
Okay,
Call you Carol and Carol.
so,
Like the waiter was happy. There was a lot of talking to us. And she was
quiet. Thank you. Before I take just definite questions, I wanna talk about what I was, throwing at you at the end of the last class, which is sort of funny that like you don't do it more than you do when you solve for, x in terms of y, as opposed to solve for y in terms of x. And also, what if you don't know what the graph looks like? How could you type it in your calculator if you have all these y's and all that kind of stuff? So we're gonna talk about that for a little while. Let's just take something simple, like for instance, if you have x is equal to y squared plus y plus, let's say minus 3. Okay? That's a quadratic, but granted, you may not know which way it's going. It's gonna be going sideways, and it'll be going to the right because my lead coefficient of y squared is positive. Not necessarily my lead coefficient when I get in a descending order, so it's like x squared. Some people say, well, I'll just type it into my calculator as x squared plus x minus 3, and then turn my calculator, but then I get confused which way to turn it. I'm like, right or left, or I mean, you can make sense of it, but if you have your calculator, especially on homework, I know sometimes you're kind of maybe rusty on some graphs and you want to look at it and then you're gonna graph it, you know, you're gonna be good at it by test time or when you need to, but sometimes just in investigating, what does this look like? You might wanna look at it on the calculator, especially if it's like a cube graph or something. Before I do anything, let's make an XY chart. First of all, what worries me a bit, and I hope we're past that, is that some of y'all would try to solve that for Y to take derivatives. Please just do implicit differentiation. It's a whole lot better than whatever's gonna happen if you solve that for Y. Are y'all with me there? I would just say the derivative of x is 1 is equal to 2y, y prime, and also in integral calculus, the inverse of that, it's okay to stick with y. Life could be a whole lot easier sticking with y. I'll show you one. Sometimes I'll show you some of my really good, some of my favorite examples off of old AP problems. One of them similar to a homework problem you're going to do tonight, and I'll show you like a couple of different ways that people attack it, but it's best if you just leave the one I have in mind in terms of y. All right, right now, x is the dependent variable. Do y'all see that? All right, so if I fill in 0 for y, x is -3. Now what's funny is I think you're going to be like me. It messes with my mind to fill in for y and find x, and then I graph it wrong. So I have to just like pause and go, wait a minute, what's just happened? Because I feel like I just filled in 0 and got -3, and I can tend to put it down here instead of in the right place. This is the point -3, 0. But my point is, when I filled in y as 0, it told me to go back 3. Do you see how it's just like when you were filling in for x's and finding y's? Now we're climbing up and down the y-axis and finding x's. And then we're going to have Riemann sums or whatever it is that we need, okay? All right, if I fill in 1 for y, I get -1. So when I climb up the y-axis, it gives me an x value. So everything's fine. You're just climbing up the y-axis, finding x's, climbing up the y-axis, finding x's. Let's see where the vertex of this is. I can still say -b over 2a. So the vertex must be when y is -1/2. Not when y is -1/2, not when x is -1/2. So I can fill in -1/2 here and actually find my vertex. Let's look at it on the calculator because obviously we could type this into Desmos, but that's not allowed on the AP exam or on standardized test yet. So I would type this in, get rid of this plot. All right, so I'm going to type it in as x squared plus x minus 3. All right, so these are some really good things to talk about here. When I hit graph, I don't think I'm on the right viewing window, so I'm going to go back to Zoom 6 to a standard viewing window. I'll do it up here. Okay. Now you can see that I'm starting to get that, but I need it to go sideways. You see while that one's going up, the other one would be going to the right, okay? If it's going down, the other one would be going to the left. But also, I can go to table and be really careful. I can copy down those points, but what do I have to do with them? I've got to switch them, okay? So in other words, when x is -1/2, y is -3.25, and so I have -3.25, -1/2. So let's look back at my table and see what I'm talking about. Where did my calculator go? Must still be up. So be really careful with your points. That you discipline yourself. These are your x's and these are your y's. All right? So now I know where my vertex is. I think it was at -3.25, -1/2. And then I've got a few points going this way. Is everybody okay with that? It's not a function, okay? But what's important is what if I was, and we'll do one of these in just a minute, what if I was finding the area enclosed there? That was sort of my big deal in the last class. You will have choices on my test and on the AP exam, okay girls? But I would choose to just do this all in terms of y for many, many reasons, okay? Well, one reason is if I do this, I have red minus red for a while, and then it changes to red minus purple, doesn't it? That means I've got to do two sets of integrals, and this one's going to be really ugly with square roots of x in both directions. In fact, I don't even think I can solve this for y. I think I'm pretty stuck here. But what would be far better?
Right to left.
Okay, right to left, and then Carl would only have one integral to set up and a more convenient integral, okay? So we'll look at both of those on one of your homework problems, and then we'll really see it. But my big deal is that, y'all sound okay? And other thing, you're sitting here in BC, so it's easier for me to, you grab it pretty fast. But as I climb up these are dy's, they're not dx's anymore, aren't they? Change in y. As I climb up the y-axis, I'm finding x values, and I'm adding up these rectangles, which is what an integral does. Okay, so if you've got to all of a sudden be wise enough to make decisions and be super comfortable with leaving things in terms of x in terms of y. Now, another thing I wanted to say that we said really fast last class, if f of x is y, then what should this be called? This is x equals, which is an f of y. Right, Emma? F of y is the same thing as an x. F of x is the same thing as a y. Think about what that really means. F of x means what's your function when you start filling in x's so you find y's. But what are you doing if you're finding f of y's, if you're climbing up the y-axis, is shooting you across and giving you x's. So when you see f of y, it's equal to x's, f of x is giving you y values. So this is all shifted over to a dy over dx. Okay, now, does anybody have a specific homework question they want me to do?
Can you do one from the AP?
Yeah, one from the packet that doesn't have anything to do with area, you mean?
Yeah.
Yeah, let's pause for a minute and do one from the packet, yeah. Which one?
It was the response to part D.
Oh, were you talking about the 2003 packet?
Yeah.
Let me see what it is to see if I wanna do that.
It has integrals.
Let me hold off on that just because of what I need to teach today, but I'll definitely get to it. And one thing that we're gonna do, talk about on that, the reason, and I'm sort of pausing, I'll put it front and center in my packet. I really wanna delve into what the words mean there, to be very little about the greatest distance, but hopefully I'll finish in time to do it. If not, I'll do it in one of the classes coming up.
33.
Alright, so this is 33. Alright, 33, great, it's like I planted you in the audience. Alright, 33 is f of y. See how they wrote it. F of y is equal to y squared plus 1. And g of y is 0. And y equals -1 and y equals 2. What we're doing right now is finite area. Ironically, in BC, we also tackle infinite area. There's sometimes we can find the area enclosed in something that's not closed. But right now, everything should close up, okay? It's just like, you know how you can find the sum of some geometric sequences, series? Similar to that, but we're not worried about that right now. Ours should close up if we graph it correctly. All right, y squared plus 1 is positive, so I know it's going that way. And I might fill in a few points or find the vertex or whatever to get my bearings. If I am making a little XY chart just to sort of get my bearings, I'll fill it in for y, and I'm getting x is 1. All right, if I fill in 2 for y, I get 5. If I fill in -2, I also get 5. I have to train my mind though to go out 5, 2, and 5, -2. All right, and there's no way, is there any way to let x be 0? 0 is equal to y squared plus 1. Not in the real number system, is it? All right, so this is our vertex, right? I mean, this is our parabola right here. In fact, think to yourself, you're very good at graphing x squared plus 1. Sorry. You're really good at graphing x squared plus 1. Excellent at that. You have x squared moved up 1 unit, so that makes sense that if you have y squared plus 1, it should be like that. Okay? All right, and then we have g of y equals 0, which is the x-axis. And y equals negative 1. And y equals 2. So we have this funny kind of almost like, I don't even know what kind of shape this is, but we have this. Looks like kind of half of an anvil or something. It's a weird shape. And we've got to find the area of this. All right, given that it's in terms of y, I prefer to keep it and go blue minus red, blue minus red, blue minus red, blue minus red. That's the way I'm going to do it the first time. That's what I prefer, okay? So don't fight with going sideways. If you're going sideways, f of y is, what's another word for f of y? X. You're finding you're going sideways, okay? So I'm going to integrate this of right minus left, dy. My y's are going from negative 1 to 2. Elaine, is that okay so far? Okay? So that was good. That stopped it for me, okay? Then I'm going to just start adding these up, which is the beauty of integral calculus and the fundamental theorem of calculus. So I'm going to have blue minus red. So I have y squared plus 1 minus 0. So I have a really easy integral to do. I haven't worked these this year, so y'all tell me if I get the right answer. Surely some of y'all have checked it. All right, so this gives me y cubed over 3 plus y from negative 1 to 2. Big important thing, make sure your limits of integration, if you're doing it in terms of y or y's. Sometimes they'll say something about x's, but make sure if you're doing up and down that you know your y limits of integration so you can find the other part of that point if you need to, okay? Which I'm going to show you that in just a minute. All right, so if I fill in 2, I get 8/3 plus 2. And if I fill in negative 1, I get negative 1/3 minus 1. A little trick that I do, even if I have a calculator, but probably wouldn't have a calculator for this one. I've told you this before, sometimes I wait and write it all down and not get a common denominator. I'll look kind of throughout the problem and see if something's going to be easier for me with the fractions. So did y'all see I have 8/3 minus negative 1/3? That gives me 9/3, which is 3. And then be careful with your signs. I think I should get 6 here.
Yeah.
Is that the right answer?
Yes.
Okay. So that area, which is really weird looking, it had a shape of 6. All right, then stop and think. I was talking to somebody in my honors pre-cal class this morning about, does that area make sense to you? Like, could it really be 6? Or sometimes could you narrow down your answer choices if you're in a hurry or you're stuck? Always remember what you're doing. Like, for instance, this right here. Do y'all see how you could find the area of that rectangle and you could start to do estimates and stuff and go, does that even make sense to me? What is this? 4 by 3 is 12. You know, so you're thinking, if I had to narrow down my answer choices, maybe I could get it. But also think to yourself, does it make sense? Okay, now, what if, I always have students that are resistant to doing it in terms of why. I would not be resistant in light of what just happened there, okay? But if you wanted to do it in terms of X, and let me warn you, I don't think you'll see it this year. But a few years ago, they were kind of on a kick of making you do it in terms of X or do it in terms of Y. I don't think that's going to happen, but let me do it just in case it does. Also, I have to, as a reader, be able to be prepared to read either one. Like, what if a student did this in terms of X? Then I've got to be able to decipher if they did it correctly while I'm rolling my eyes, like, why did you just do that, okay? It is important for volume, so just stay with me. So don't I shouldn't have said all of that, because you might tune me out if you're thinking, well, I'm not going to have to do it. When volume comes around, we're just doing area 2 dimensions. We're about to do 3 dimensions. They're so much fun and incredible. But you may find this necessary with volume, with 3 dimensions. So watch what I'm going to do here. All right, so since this is on video, we have a record of all of this. Let me get rid of it. So many students, unfortunately, just fight against solving for solving for x. And so they might change this and say, they might change this and say x is equal to y squared plus 1, x minus 1 is equal to y squared. When you square root, don't forget your plus or minus. Okay? And so I have this. My most important number is 1. So green is plus square root of x minus 1. Purple is minus square root of x minus 1. And then what were we going from? Negative 1 to 2. And the x-axis, or the y-axis. All right, now here I'm going to have red minus red. And there are going to be times, girls, listen, that you're going to have more than one region. Sometimes I cannot escape it. I will try. But we're going to run into things where we've tried to do it sideways and up and down, and I've got 2 regions and I just have to deal with it. That will definitely happen to you on my tests, okay? I would get away with it if I could, like Carla noted, that I could just go right minus left, okay? Sometimes we're stuck with 2 regions. This is red minus red. This one's red minus green. But what's this one down here? Purple minus red.
Whoa.
Yeah, okay? So I should be able to integrate it red minus red until I get to 1. So let's try that. So I'm going up and down. That means I'm doing y's. You're going to have to start getting this straight in your mind as you head toward volume. You've got to make really wise decisions about what you're doing. These are y's. All y's are vertical. They're like f of x's, okay? The x's, or f of y's, are horizontal, which makes a big difference in the next class and the next one. All right, so here, I really don't know that I would even do calculus. I mean, I would just find that geometric figure. Do y'all see that? But it should work if I go from negative 1 to 2. What's on the top is 2 minus negative 1, so I have 3 dx. Then I've got to find this green one, which is the square root of x minus 1 minus 0. That's wrong. This region right here is what I'm doing now. This region is red minus green. So this one is going to be 2 minus the square root of x minus 1 dx. And this is going to go from 1 to wherever those intersect. So I've got to find out where the square root of x minus 1 intersects 2. So if I square both sides, I get x is equal to, I believe, 5. We'll find out. Then I have another integral. I have 3 regions. So now I have purple minus red, this little bitty thing down here. My graph must not be very good. But I have purple on the top minus red on the bottom. And that's going to go from 1 to somewhere, I don't know where. And the purple is negative square root of x minus 1 minus negative 1.
Could you do this in 2 by just doing like green minus red and purple minus red? Like the other way?
No, because then you're going sideways. Do you see what I mean? And if you're going to do that, then you would just
switch everything.
do the whole, yeah. You've got to switch everything to dx.
But you could.
Okay,
That would be like
but
that.
what we would do is just what we did at the beginning. If you're saying
Yeah.
that, Carla,
Yeah.
I would just keep this as y squared plus 1, and I would go
I'll
purple.
just do
Why would you
Yeah.
ever switch to x?
She just said that they like specifically asked for it.
That's so dumb.
There's 2 reasons I have to do this right now,
Missed that.
okay? Right now, with area, you many times have a choice, and you would choose wisely that Carla keeps talking about, okay? I would never choose this, but I can't tell you how many students I teach, not so much in BC, but that fight against, and they want to solve everything for y. Sometimes it's impossible, okay, to solve everything for y. But some people are like, I just can't do it, I'm just going to do it all in terms of x. There are going to be things that we encounter, though, that no matter what we do and how we look at it, there's more than one region, okay? So no matter what happens to me, sometimes I've got to do 2 regions, no matter what. Let me give you one. I'm, hesitant to like make one up, but I'm gonna come back to that in just a minute. Oh, the other reason is when I get to volume, there's two things I can teach you to find volume of a 3D object. One of them is called by disk, and another one, or disk or washer. I'll get into that on Wednesday. Another one is called by shells. A lot of AP Cal teachers or college teachers don't even teach shells anymore. But you've got to do disks in terms of certain variables. If you know disk and shells, you can make wiser decisions. And so with the time factor right now, I'm probably only going to be teaching disk and washers. I probably won't teach shells, but if time allows, I'll teach both. But it kind of doesn't matter what I pick. There's many times we can't escape more than one integral. So Morgan, that's why I'm doing it. Hopefully you're looking at this going, why would I err? I think I've convinced you that in this problem you don't want to do it in terms of x, right? Okay, but you'll see. I think it's just going to come from you making more problems like this. Suppose I have purple, red, and blue. Okay? I'm stuck any way I look at it. Blue minus purple, blue minus red. Y'all see that? That's two regions. Or I could do purple minus red, but I'm gonna have to switch over to purple minus blue. Y'all see what I mean? I'm stuck with two regions no matter what I do. So then it's just a factor of in which form of the equation is easier to deal with. So stay with me. All right, I'm just curious to see if I'm even going to get a 6 out of this. All right, so this is 3x from -1 to 2, which gives me 6 minus -3, which I guess the area of that thing would have been 9, which is kind of scary. All right, the antiderivative of this is 2x minus, I do substitution, x minus 1 to the 1/2. So it's going to be x minus 1 to the 3/2 times 2/3 from 1 to 5. This is making me really nervous. I'm not even sure I did this right. All right, then this one is going to be the negative of that, x minus 1 to the, I guess it's 1 minus that. I think I'll do that. So as I'm integrating this one, I'm integrating the 1, which is x, and I'm integrating this one, which is minus x minus 1 to the 3/2 times 2/3 from what to what? I can't even read where my
We didn't find the
limits of integration.
It's one.
Oh, I didn't find it. It's from 1 to where negative square root of x minus 1 hits what? -1? So it's where square root of x minus 1 equals 1. Minus 1 equals 1. So I think it just goes to 2, which looked like it was a really short distance. Seems like kind of a miracle that I'm going to get. This is going from 1 to 2.
Oh goodness.
Girls, pause for a minute. I got away with this, x minus 1 to the 3/2 over 3/2 or times 2/3, because I did think about u is x minus 1, du is dx. If I had 2x minus 1, do you see I would have to compensate for that? So then I have to leave this problem as is for a minute and go off and do substitution. All of this can happen to you. This is a relatively easy problem as far as doing it in terms of y is concerned. It's a much tougher problem in terms of x, but we're not going to avoid the tough problems. Like, that's not going to happen, okay? Now, after all that lecturing, let's see if I actually get the answer. So I'm going to fill in 5. It's going to give me 10 minus 2 times, if I put in 5, that gives me 4 to the 3/2, and it is 8 over 3. Minus, when I fill in 1, right here, I get 2, minus, and when I fill in 1 right here, I get 0. Plus, now I'm on the next integral. When I fill in 2, I get 2 minus 2/3. And when I fill in 1, let's see, I filled in 2, so that gave me 1. When I fill in 1, it gives me just 1 and 0. So, well, I said over
What
3.
happened to the 3 halves? Did you use that?
I did. When I filled in 5, I got 5 minus 1.
Well, I meant on the second part. Is there not one there too?
There is. When I filled in 2, I got 1
Yeah.
to the 3 halves.
Oh, yeah.
Doesn't look like there's any way I'm gonna get 6 out of this. 10 minus 2 is 8, minus 1 is 7. This is huge right here. Minus 16/3. Minus 2/3. So I get 16 minus 6. I don't know, I feel like I did something wrong there. Cause was the answer 6?
Yeah. Uh-oh.
Yeah. Uh-oh.
Yeah, it's okay. Did I do the first part right?
You forgot the 10.
I did 10, minus 2 is 8, minus 1 is 7. Oh, but I have this 2 right here. These cancel out. So it's even worse. The front part is what's bothering me more than the back part. 3, where did I get 3? Where did I get that number? I can't even remember.
You did the.
Oh, I did top minus bottom.
Yes.
So I did 2 minus -1 is 3. Would the area of that be 9? Oh, I know what I did wrong. Okay, sorry. I kept my y limits of integration right here. Okay? If I'm going to go top minus bottom, I need to go from 0 to 1. That seems like a mighty big area. So that should be just 3. Yeah, that should just be 3. So this is going from 0 to 1. And so this one is just 3. I don't know if that helps anything. I don't think it does. That's 3. And it's a big mess too. I can't hardly read it. 10 minus. I tell you what I'll do. I'll write it out on a sheet of paper and just send it to you. It'll be 6. It's just so messy up here on the board. And I don't want to spend more time on it right now, but suffice it to say, I'd rather have done it the other way, okay? Girls, I always do an example. I don't, always mess them up. But I always do an example where you could do it with 2 regions or 1 region. Before you go, I wanted to do this. I got 2 minutes. In your book, you have one like this, where you have f of x is equal to 1 over x squared plus 1, and they gave you a point. That's not an interval, that's a point. And the question says, set up and evaluate the definite interval against the area of the region bounded by the graph of the function and the tangent line. So you want to find the area enclosed between the function and its tangent line at that point. So you've got to do a lot of calculus, all right? So first of all, I'm going to find the derivative, which is low d high minus high d low over low low. I'm finding the slope, girls, hold still. I'm finding the slope at 1, okay? So f prime of 1, this is 0, is -2 times 1 over 4. So the slope is -1/2. Everybody be quiet for a second, so that I can really get this point across. You heard me read it, set up and evaluate the definite interval as the area of the region bounded by the graphs of the function and the tangent line to the graph of the given point. You're like, what? You know how an AP problem sounds. Break it down, break it up, do what you can. I see the words tangent line at the given point. I'm like, well, I could do that back in the fall. So that's what I'm doing right now. Do you see I'm finding the equation of the tangent line at that point? So I'm just gonna calm down and go y minus y equals m times x minus x. If you rearrange that, that gives you y equals negative 1/2 x plus 1. Okay? And then I'm gonna need to graph this because I want the area enclosed between this and its own tangent line. Alright, do y'all know what that looks like? If I fill in 0, I get 1. If I fill in 1, I get 1/2. And it looks something like this. So if I graphed it bigger, you would find that area right there. Okay? I think that I need to draw it more this way though. I think the curvy one goes on the outside. Again, in interest of time, I'm not gonna stand here and make you sit here with me while I graph it, but I would need to graph that one carefully if I didn't have a calculator. And I'm gonna say before you go, how to even know sort of the shape of that graph, okay? What's gonna happen, what's your limit as x approaches infinity?
0.
Bigger on the bottom than on the top, right? So it's getting closer to 0 and it makes this sort of classic bell curve. And then you would do top minus bottom and find the area. You have that one for homework, Bob. So I'll post your homework, and bring your food.
I'm so hungry. Oh my god. Do your cake. How much sushi do I have to get?